excuse my accent. I'm not from this country. Immigrant, some 30-something years ago, entered this country. I was a physician. I'm doing my postdoc now. I was a physician, hematologist, oncologist at one point, and the hard knocks were really those years when you see so many failures and so many deaths, and you feel helpless, and you, over 7 years of clinical practice, you identify essentially what the most important problems are. The problems that you cannot solve, and you need to find a solution. So, and then you look at statistics, because statistics have been around for hundreds of years, and in some countries they're very good, some very bad. But you start to find out, what is it that most people suffer from? What is the most frequent cause of pain and death? These are the most important problems. Now, I'm not saying that we want to prevent death to happen, because that's not possible. But you definitely would like to reduce pain and suffering, and that's what the oath took me to. And I was coming from Eastern Europe, where it was very difficult to do research, but I had some ideas, and I had some patients that unfortunately died, but I learned from their death and from the research that I've been doing, and came to the United States. Was invited actually to work at Scripps Clinic in California, which is a fantastic place to learn how to do science, because I really didn't know that. And my mentors and teachers and colleagues there inspired me so much that I was thinking about solutions to problems that haven't been available. It takes in biomedical research, which I've been doing ever since at various places, it takes a long time to mature an idea, and the more you learn about it, the less you know. And this is a different business than what we have heard until now, and I'm envious of people who can just come up with an idea and do it. This is trying to make a drug or several drugs for some disease is an enormous task. It's like some people try to make cars. Like 100 years ago, there were like 5,000 car companies in the United States, and eventually there are only 3 or 4 now. Tesla is the 4th, but the rest is a few. It narrows down. The difficulties are so enormous when you are creating a product that can actually kill people instead of helping them. Resulted in a process that is now called good manufacturing practice and good clinical practice and good laboratory practice that are now regulated by the government, and you cannot sell a product without manufacturing exactly the same product over and over again. And only the very big ones can essentially do this. And this is what the small companies couldn't do. And that's why I'm a big wonder, I think, is that Tesla has come to the market, the electric car, because I never thought that there will be another company in the United States ever that can come up and make a product. But I started to think about these drugs that I was thinking about because of the clinical experience, and then I learned some biochemistry over the years and then molecular biology, whatever is needed, the tools for putting together something that is extremely complicated. It turns out that biomolecules biologicals, as the FDA calls them, is essentially the top of the technology, whatever technology is. It's far more complicated than electronics, computers, or anything. And even when they come out as products, eventually, you still don't know exactly what you're doing. The system is so complex, even a single cell, that you are creating something that is that you don't exactly know what you're doing. So we are. I founded a company here in Portland to cut through 20 years of thinking, and because I had a couple of ideas, and then I figured that I need a lot of money to do what I would like to do, which are drugs, essentially to treat medical emergencies. I don't know whether you guys know that when somebody falls on the floor somewhere, there's the thing that happens to this person is that he can have some serious disease, heart attack, stroke, whatever. Nobody knows what it is. Then somebody calls 911, and if it's lucky and there are somebody around, and they come, and then they rush this patient to the hospital, and then they figure out what the disease was and try to treat it. In a city like Los Angeles, the period, the gap between the event and the hospital treatment is over 120 minutes, average. If you imagine that in 120 minutes what can happen to your heart, to your brain, this is the area which I thought was a business opportunity, also as a medical need that you have to address. We conveyed this idea to the NIH, and the NIH was very supportive to that concept of treating cardiovascular emergencies, providing or generating treatments to the treatment gap which exists from the presentation of a disease, cardiovascular disease, and the treatment. And they just said at NIH that, you know, what you need is a safe drug, because you don't know what the problem is. But if you give this drug to the person, if he has the disease, it may help. If he doesn't have the disease, it shouldn't hurt. And this is the key to the emergency treatment. Now what the paramedics do, they give you oxygen, because everybody knows that oxygen wouldn't hurt. They put in an IV because IV wouldn't hurt. They put you in a stretcher because it doesn't hurt. But that's about the treatment you get. So I thought, we're going to think about drugs that don't hurt. And we came up with a couple of ideas that they didn't just come up. I mean, we worked on this really hard. And raised some money from the NIH, SBIR funding, and we were pretty successful in this funding. Private funding is not available for this kind of thing because everything failed so far. But the reason why there is no disease, no drugs on the market, because everything fails. And we raised in about past 3 years about $15 million to support the manufacturing and the creation of these products. And during this period, I learned very hard lessons. I'm not a businessman, and I haven't been. I'm primarily a physician, or was a physician, but I still am at heart. But I would like to create new drugs, and I'm working with a very few very talented people. The company is only 7 people now, employed, actually 8, but she's just temporary. All 7 of them are very committed. They are all very highly trained, and they know what they are doing. And that is a very important thing. We learn on the job at the same time. So it's hard to tell you lessons because I haven't been through that many times on this. You know, what was the hard part? I tell you, there were a lot of difficulties. A lot of difficulties with how to make a product that you can actually pass through all the regulatory hurdles. And I figured one thing: I'm not delusional, and I think what we can do and what we will do is to pass on this product during development to somebody who can actually do this. And we have been pretty successful. We have 3 product candidates. 2 of them are now out-licensed to a major pharmaceutical company, which provides some income for our little company to work on the 3rd product candidate, which I also would like to out-license. And because it's not because I like to out-license things, but those are the big companies are the ones who can actually do this. And we have other product ideas. We are 8 people, and per capita income, I think we are probably the best in Oregon. And in raising funds. And this is because we explained and we know that we are trying to solve a major, major problem. We are not adding something, we are creating something that's not there. We are not like the others. We are going to get into a new domain, and this is going to be extremely, extremely difficult. I don't know what to tell you. You know, it's learning and learning and learning every day. Is that what is probably the most important thing? Working with the others and ask everybody you work with to study, learn, and be innovative. Try to do something new that has never been done.